consultant at Norless Software. And the topic that I'm going to present today is GraphDB in microservices architecture. So let's begin with the agenda of this presentation today. So first we'll see what are microservices, right? Then we'll look at what exactly is a GraphDB. I'm sure a few of you might know what exactly the term means, but we'll look into detail what it is and what it is used for. Next, we'll look at the need, basically the need of GraphDB in the microservices world. Then we'll look at the challenges and the solutions that we actually face, and we can apply those solutions in those situations. And in the last, we'll see a real-life example for the GraphDB in microservices. Now, before I begin, how many of you have heard just the term microservices? You can just raise your hand. Quite a few, right? And it's not a new term now, right? But about 3 or 4 years ago, hardly anyone knew about it. So the microservices have grown about 4 times. Basically, its use, or basically just interest of industry, and microservices has grown 4 times over past 3 years, right? And every other company, whether a big or a small or medium-sized company, they want to lay their hands on microservices. Now let's see what are microservices. So microservices are a variant of SOA architecture, right, that structures an application as a collection of loosely coupled services. So basically, you just divide your application into smaller pieces, right, just so that you can make them, build them, and deploy them in isolation. Correct. So that's what a microservice means. It's the same service that we actually build in an application, right? But totally built, deployed, and running in isolation than other microservices, than other actual services, right? Now, these are the 3 features of a microservice due to which it got so popular. The first thing is it's lightweight, right? So microservices use the fine-grained and the protocols are lightweight. Today, we use protocols like HTTP, TCP, and foregoing gRPC protocols for consuming these microservices, right? And all these protocols are very lightweight. These can be used or basically consumed by any consumer present out there, right? For REST API, we can just use an HTTP protocol, right? For binary calling, we can use gRPC and other things. Next property is they are modular. By modular, we mean that they can be built and deployed in total isolation, that it will not affect your other services. That's why a few of the companies today have built and deployed thousands of microservices, right? They have just divided their whole platform into smaller microservices, right? So that even one is undergoing a redeployment or kind of like a building or some kind of a development is going on that one, it will not affect your other microservices, right? And the last one is continuous delivery. Of course, you can just build and deploy it in real time, right? You don't have to wait for other pieces to be in place. So for example, like if there is an application for trading, right? We can simply deploy the login service for that trading platform without affecting the trades which are going on, because that will be too loosely coupled, right? So the trades doesn't have to be related to login, right? They don't have to be. That's why.
How microservices different from SOA?
How?
Microservices different from SOA?
No, so they're not different. They are similar, right? But they are just loosely coupled from each other.
But in SOA, we have a similar type of things, like we have applications, they are loosely coupled.
Yeah, so microservices is just a type of SOA. It's a subtype of SOA.
So, like microservices are but they do not have that deployment aspect to them, which the microservices have.
Yeah, I mean, like in a single app container, when you have multiple services going there, there would be SOA, and in case of microservices, I think there would be a single container.
So SOA is not actually focused much on principle of isolation. What SOA suggests is that you should basically create your application into part of different services that can be consumed. So it basically specifies a interface, right, that we basically need to build it as a services which can be consumed by multiple clients.
I think it is kind of a basic similar concept, but it was not very famous because they did not tell us about how to orchestrate that data. So, like the coupling is there, everything is there, but it was not very famous. So, microservices got famous because they tell us how to like work with microservices in terms of environment, keeping them open, how should be the domain defined, something like that.
But we can do similar things as SOA as well.
Basically what happened is
but it was not famous.
basically SOA, and people tried with SOA. So the reason of their failure was that the underlying problem of inter-services dependencies were not resolved. Okay, so basically what used to happen was that during the initial implementation of SOA, right, because I was part of those projects, it used to be that we have basically wrapped it around the REST layer. Okay, but the underlying infrastructure and everything used to be same. Was no isolation of database, right? So most of the services that we are doing, they will be using the same database. So what microservices actually defined was the isolation, okay, plus how you should build those services, right? So those are the principles which are defined in microservices. So microservices is not different from SOA. It is part of SOA only. Okay, it is just a way of implementing SOA.
Okay, it's just a way of implementing.
Great. So let's move forward. Next that we're going to look towards at is a GraphDB, right? From the name itself, we can understand that it's a database, right, that uses graph structures for semantic queries with nodes, edges, and properties to represent and store data. So basically, it saves the data and its metadata, that is the relation between the different types of data present in the same store, right? Now, why we are even talking about the GraphDB now? So GraphDB over the past 5 years have grown so much popular that it has been one of the most interesting topic for the decade, like for this decade, right? So even according to an article in Forbes magazine, GraphDB is going to be the database for the decade of 2020-2030, right? Because of its properties. Now let's see what are those properties of a GraphDB. No SQL, right? So basically in the era of 2000 to 2010, right, the NoSQL databases like MongoDB and Cassandra took a lot of pace because of their NoSQL feature. That is, you can run your SQL queries as well as your random schema queries as well over those databases. So the developers were not bound by the schema that was present. It was totally flexible and modifiable, right? Next is fast. Now we can develop the same kind of graph structure using Cassandra or any other relational database, right? But we have to use joins inside it, right? Basically to represent our relationships. Now what GraphDB says, or GraphDB does it helps you save the data in that relational form itself, so that you don't have to run or like write those joins in your code, or basically in your ORMs. So it's fast in that perspective. Next is intuitive. By intuitive, we mean that you don't have to define the schema before you actually start adding the data into the database. In all the relational databases, right, or Cassandra or MongoDB, or not the MongoDB exactly, but we have to define the schema first, and then we can start using it. Right? That's the most efficient way it used to be. But for GraphDB, you can just put your data in there, define the relationships, and that's it. You can retrieve it the way you want to. So we are not bound by the schema anymore. And the last one is scalable. So like any other database which is present in, which is like present there, relational or NoSQL or whatever, it's scalable. You can just scale it horizontally or vertically in any form you want. Right? So these are the features due to which the GraphDB is becoming popular nowadays. Now let's move on towards the need for microservices with GraphDB. The first benefit that we get, or the first thing that we would need with this combination is metadata management. So, for example, let's take a music playing site, right? Like Rhapsody or iTunes, right? Basically, on these sites, you just create an account, right, and start listening to music. Correct. Now, if we have to create the same platform, then our metadata would be that which songs I have listened in the past, right? Or I'm just listening to, or which I have purchased, or I have uploaded on iTunes as an artist or as a singer, right? So this is the metadata I just want to be there. Now that metadata management is quite tough in your relational or traditional databases, which is eased by a graph database, because that's just a relationship, right? So in the forward slides, we will see an example of the same scenario, and from there we'll get a deeper idea or a better understanding that what exactly this metadata management means. Next is, of course, your master data, your user information, your song information, and your like artist and purchase or those information is, you also need to manage that one. Third need is building knowledge base. So has anyone here heard about the data lakes or the knowledge base platforms?
A bit of knowledge base, not exactly, but yeah, these are the systems where they are grooming on to the existing data. And so according to user if users will do something like some kind of search, so that handled by, or that they are searching to the knowledge base system, something like that. Similar to the AI part, or
it's kind of similar to Google, right? So what you're saying is correct. So everybody here have definitely used Google, right, for any kind of a search that they have used. Now, how Google is able to find the results for you from over the web? Simple. It just keeps a data lake, or basically a knowledge base, from where it just shows you the results. That okay, I want to search about a particular song. I just have to type a few keywords and it will start showing me the results, right? It just picks those values from its knowledge base. Now this knowledge base needs flexibility. The flexibility in terms of schema, the flexibility in terms of extendability, right? So I cannot define that schema before I start building the platform for that knowledge base. For example, the songs, or basically the kind of content that is being generated today, is totally different from what it was 5 years earlier, correct? It has more metadata, it has more relationships, it has more like kind of value there, right? I want to store that extra information as well. Now, if my schema would have been kind of bounded, I would not able to do that, right? So I need a database which can handle that one. So GraphDB helps us there as well, and others. For example, for machine learning, right? For AI. Right. And for these kind of use cases, the GraphDB is getting a lot of popular.
we can perform the same thing with the other databases as well, like machine learning or fraud detection.
Of course, you can.
So why is the GraphDB so popular?
So, just like I said, the third use case, building a knowledge base, right? So basically, you just want to create a data lake where you can just dump your data without even considering what exactly the data is.
We can do this with other databases.
Yes, we can.
like in MongoDB.
In MongoDB, right? But there you have to again define ORMs and other things along with it. But in a GraphDB, I don't have to do that beforehand. I can query it the way I want to. So it's not bound with those kind of relationships. We'll see an example. Of course, you can use any kind of database for any kind of a use case, but it's more suitable than those databases. How? We'll see there later on. So now let's move on towards the challenges that we faced while integrating a database with a microservice or microservices architecture. So the first challenge is decoupling of microservices sharing same database. Now, according to Werner Wiggels, who is the CTO of Amazon, right? He wrote a book on microservices architecture. In that book, he clearly defined that all the microservices should use their own database that should not be shared by any other microservice for decoupling or isolation purpose. Now, this particular challenge we cannot address in a GraphDB because your source of information is just one. You cannot have a GraphDB for each and every microservice that you develop. Correct. Now, how to address this challenge here? So, let's take up an example and understand it through that one. So, for example, I have a platform where user can listen to songs, right? An artist can upload those songs over that platform, and a user follows another user, right? So, this is a simple graph or a relationship that is present in the database. Now, how to split above model in different microservices for better decoupling and fault tolerance, right? How would I split this whole architecture or this graph into different microservices so that I can build this platform, right? Now, let's see the solution for that one. Split each different entity into its own microservice using a document store to persist the data on each service, and then define a higher service to manage the relationships. So basically, we are dividing these microservices into two categories. First category manages your master data, which is the information about your node, that is user, song, and artist, right? And other microservices, the second category is handling your relationships. That is, the user is listening to this song, artist has uploaded this song, right? Or this user follows this user, right? Now, that resulted into the following architecture like design for the microservices. So here we have a total of 5 microservices. First one is user microservice, second one is for songs, and third one is for artists, right? So that's for my master data, simple. And second one is the friendship service, or basically the follower service, where I just want to see which user is following which user and kind of vice versa. And the last one is the recommendation service, which actually recommends music to the people or the users which are present there on the platform. Right? Now, friendship service and the recommendation service is just using the relationship or the metadata to basically perform its operations. Now, do we see any challenge in this particular architecture or design? Both are using user service, that is correct.
And both are creating some relationship with the user, right? So they are embedding into the domain of the service.
That is correct. Any other issue in this design?
We have some common database, like all of them would have common database that needs to be resolved.
That is okay, but we solve that problem through bounded context, right? So we bounded the user, song, and artist service to just the master data of each and every node, and friendship and recommendation service to just the relationships that is present among the master data, right? So that particular problem we have already solved here.
What is the song service? Why we are splitting song?
Why we are?
Why we are splitting creating a song service?
So it's just a way to decouple your services.
But
Right.
song is actually, I guess, depends on the the user is only responsible for uploading the song.
Yeah, so we are thinking in a graph manner here, right? That they are related, so they cannot be separated out. But if I just want to see songs information, like how many songs are there, I wouldn't go to the friendship service or to the recommendation service or user service. I can just simply look at the song service. That, okay, list me all the songs which are present there, or list me the song for this particular genre, right? So that is what it is defined for.
One more problem that I see is that we have very finite level services, right? So basically now, if we are basically breaking it into a different entity,
Right.
then I will be, and maybe these two entities are tightly coupled, right? And they are basically cohesive.
Correct.
But still, I am basically treating it as a different service.
Exactly. So that is one issue. So in layman terms, your recommendation service is actually dependent on all other services. Correct? It cannot work in isolation. You cannot just remove it out. Right? Recommendation service will fail if one of the other services will simply stop working. Right? That is my challenge number 2. How to reduce the number of dependent services that we have. Right? Again, the same example that we already have seen. Now, how to reduce the dependency of recommendation service on users, song, artists, and friendship services? Any suggestions? How we can simply remove that dependency? By making? Yeah, that would just make them reactive, but not independent. Okay, let's take a look at the solution first and try to understand what exactly we can do here. So what we can do is we can just simply have 3 services which are totally independent of each other. First one is your users, second one is songs, and last one is the recommendation service. Now user service, we can use that just for login and user information, right? I just want to log into the platform. I don't need recommendation service there, right? I can just simply create a login API there. Second one is song service, again for listing down songs which are present there, right, and other things. And what recommendation service is doing here, it's handling your friendship, artist, and basically the recommendation related operations, which are totally independent of your user and songs. So basically what we have done is we have taken all the relationships into one microservice, and that is responsible now for handling my metadata. Basically the relationship between the different types of data that I have, right, or entities, I should say.
But in that case, they are using the same database.
They are using?
Same database.
Every of the service will use the same database, but we have bounded them on the basis of some category that, okay, user service will only access my user data. It will not access any other kind of relationship, because I just want to log in, right? I just want to see user information, my information, I just want to see that one, right? For a song, I just want to see a song's information. But recommendation, that is what is showing me the relationship between different users. Okay, what kind of information, like user John has listened to these songs in the past, which might be of interest to you because you follow that user, right? So these kind of recommendations we do get on any kind of platform, right? YouTube or kind of Amazon or Flipkart, right? Where we see the users present in your area have purchased this thing as well, or other people who have also bought this product along with this one. Those kind of recommendations, right? For that, I don't need any kind of.
So if user follows some other users, is it okay to move it into the recommendation service, because that is something related to the user ID?
That totally depends on
how many followers I have.
That totally depends on your bounded context. Like what exactly recommendation service is handling there. I can just define a different friendship service, which will be just handling your friendships. But since recommendation needs that information, that what recommendation I should provide to you, because you are following these users.
So in this solution, we are just going to use a single database, right?
Yes.
But it goes against the philosophy of
Correct. So here the underlying issue is the same, that we are using the same database. So there can be situations where we are changing the data which is present, which it should not be updating. Right? That's why we are creating. That's why we are just limiting its reach to the data which it should be updating. For example, user John now follows John like Bob, right? And now that relationship is not there. I just want to not follow that user. So I'll be using recommendation service, not the user service layer.
So the main concern is that in that case, you will have to like keep a close eye on what the team is doing.
Exactly. So that
is not scalable.
That is more sort of a control or a quality control there, not exactly your issue between your microservices, right? Because if we define the bounded context properly, right, then I think the database which we are using, if the database we are using different one or the same one, that doesn't matter at all. But of course, for sharing purpose, we can do that, but only to the read access, not for the update mode.
So there you have identity bounded context. So that is something subdomains you have divided.
Okay.
So you're writing these subdomains. So now what you would recommend, or will it keep it like this, that the recommendation service will directly go and access the database which has been shared by all these three, or will it go through any one of these service and then it will be accessing that database? I think it should be the former one. Make sure, like, what would you suggest here?
I didn't got your question.
It's like the recommendation service will directly go to the database and do whatever thing it wants to do.
Right.
Will it, say, for example, if it's something user-related thing, or it's something song-related thing, or will it go through these two services?
Okay, so for that purpose, you have to strictly use songs service. If you have to update anything regarding your song. So in recommendation service, I will just simply update the relationships, not the data itself. Exactly. So, for example, if I just have to upload a new song, I'll not go to the recommendation service, right? But that song will automatically show up in my recommendations as soon as it is uploaded, based on some algorithm which might be running in the recommendation service, right?
But like in our last example where we were facing the problem, in that case recommendation service is actually using the services, but in that case it is using a directly database. So
Correct.
the problem is still there.
Directly using it.
Directly using the database. In our earlier example, we have a different database, but why are we required fetching the data?
So in this and the previous example, we are using the same database.
Okay, in the previous example, we were using the same database.
Same database. We just have reduced the dependency of recommendation service on using songs.
If we were using the same database, then why recommendation service depends on the song service?
Depends
In that
on.
case,
So that was one of the way which we can divide our microservices. It's not the final solution, right? There are many iterations that we have to do to reach to the final solution, right? So these are just the challenges that we actually face. Sorry. Any other questions that we have?
So this recommendation service, can it recommend songs if the song service is currently down? Because in somehow recommendation service would be using the database song service.
So, okay.
In that case, like can it be done? Can recommendation service use the knowledge base which is already in place?
So what we're trying to say is, what if one of the songs which is not available and is recommended by the recommendation service?
He's saying the song service.
Song service is down, okay?
Now, recommendation service basically wants to recommend some songs to the user, and how would it do it?
Right. So when you will just go and click on that song and you will try to listen it, it will basically access the song service. It will not show you, right? But in the recommendations, you will still be able to see that these are the songs which system is recommending for you, right? So
since it was using the same database,
Mhm.
same database.
So my database is not down, my sound service is down. If my database is down, all the services will go down. That's like a inherent problem that we have in here, right?
Like here we are violating our principle.
Sorry, which one? Yeah, that's of course we are violating it, right? But we are trying to find out a solution so that we can use it. Right?
So actually just a quick thing to add here, that I really think it is mostly recommended to make your microservices eventually consistent, so that they are not interdependent on each other. So let's say our recommendation service has a lot of coupling on all these services where they are like dependent.
Right.
So if it would be like reactive, if it would be like eventually consistent, and if we will like make these user service, sound service more available in the system, one of the instances goes down, but other instance is like already available. So in that case, the decoupling would also be there. There would not be a single database, and like your services would be available and eventually consistent. I mean, like that is the best case scenario. I'm not sure like how it really works with the graph database that is recommended.
Right. So yeah, those challenges will always be there, and we can use that approach as well to make the services decoupled, right?
Maybe we understand that.
Maybe you can take this as well. Okay. Now, the third challenge that we are going to face is add another entity into the database model. So, like I said, you can use the graph database for a knowledge base as well, correct? Which is extendable in terms of a schema. What if I want to add another relationship between a user and a song? For example, a user purchases a song, right? That's a new relationship for me there. That's a new metadata. How can I handle this change through my microservices? Simple. Create another microservice which will handle this relationship. Right? Simple. I just want to purchase a song. I can just go to the purchase microservice and create that relationship between a user and the song itself. Right? It's kind of a very extendable solution, but yes, it will have its disadvantages as well. Any questions in this particular solution? Okay. Now, there can be many of the challenges which will depend from case to case, right? Like how we will do decoupling, how we will handle the the database failure itself. Because if my database gets down, everything will be down there, right? All the services, the whole platform will go down. So my whole purpose of using microservices is not fulfilled there, right? But there are other ways to cater it. For example, we can use a cluster for your database, right? It's a distributed database. We can use multiple machines there. Now, if one of the machine or two machines goes down, I don't care. My database is still able to handle that one. The same way we do with Cassandra and MongoDB, right? Which were the first distributed databases, and even now the relational databases are becoming distributed to handle these kind of situations, right? So there are many other challenges which will come according to your case. This was just an example how, like, what challenges you can face along with your graph database and microservices. Real life example. So as I said that graph database is still growing, right? And it will be the most prominent database in the next decade. So the real life examples are very, very few. Those are kind of just in like kind of development phase right now, not exactly building up. So we are still exploring what who else has done the graph data. We use the graph database with the microservices architecture there. Right. So there are a lot of companies which are doing it right now, right? But that's not in production yet. So these are my references, right? So if you have time, you can go to the second link. It's the article from Forbes magazine, right? Where they have said like how or why the graph database will become the database for the next 10 years, right? So it will be the most prominent database that will be used. And other two are just the random thoughts put in by developers over Stack Overflow for combining these things. So like I said, graph database with microservices is a kind of a new concept which is still being explored. So finding a concrete material on this thing is still hard. So it's like all the sources are scattered away. Any questions that we have?
So does GraphDB basically support relational queries, like where we get to know that this entity is related to this entity and further it is related to some entities?
Yes. Like to answer your question, yes, it does. How? That totally depends on the use of that particular database. So there are databases which keeps that data in document form, like just random documents and links between them. And there are databases which, graph databases, which actually keep the data in relational database form. So they perform the join at real time. One of the example is Sparkle, right? SPARQL. So that's a language which was developed to query your relational databases the way you query a graph database, right? And then
those operations would definitely be expensive because you will be performing joins. Internally, they'll be performing joins.
That is
basically, I think the use case of the graph is more from the perspective of your relationship, right? It is for OLAP queries, they're still working on basically making it more efficient. But the primary use case of graph is where basically you have to go to a node and then you can fetch all the related information to that node in I think nanoseconds of time. Right? So basically that is the actual primary use case where you want to use graph.
But I think, if I'm not wrong, graph is actually used where relationship has some property.
Right. So basically it is
like we have a user is a friend of another user, but which type of friend is it? Is it a best friend, good friend?
that is not that is just the use case. So basically it is not dependent on that. It is basically used to just depict the relationship, right? Because in every real world problems, right, you are actually connected via a graph, right?
Yeah. Yeah.
So basically if you have to fetch a hierarchy and if you know which node to go,
Traversing the
hierarchy is very easy.
Very easy.
Because it's a tree, right? So you hit the node and then you can get everything.
Actually, in the book, there is a book, No SQL Distilled by Martin Fowler. And in this book, I guess he mentioned like the first thing is like that this if relationship has some properties, and the second point is like if we want to search in-depth relationship. In that case, GraphDB actually comes into the book. So that book is really amazing. I guess it's something like comic, but everyone needs to read this. No SQL distilled or distilled no SQL. Okay, and we have 57 seconds. Do we have any question?
We will ask the question only.
So okay, I guess, yeah, and
okay. So that's all from my side today. Right? Please submit your feedback over this presentation. That will help me in improving my presentation next time. Thank you, everyone.